Welcome. Let's do a problem involving velocity. The table shows the velocity of a remote-controlled toy car as it travels down a hallway for 10 seconds. I think this one is in your notes. I hope it's in your notes because this is a good question. And I do want you to add this to your notes. If we find the area under the velocity curve, we get the distance traveled. That's pretty interesting, right? So if you sum up all those velocities, what you end up getting is the distance traveled. All right, so we're going to do, first of all, a right Riemann sum. I already put the rectangles in there, the lovely drawn rectangles with the little glitch in the board in the center there. And actually, the rectangles are going to look exactly the same. On the next page, we're going to do a left Riemann sum, and then we're going to do a midpoint Riemann sum. The rectangles will look identical, whether it's a right Riemann sum or a left Riemann sum. What's going to change is what value you use. Right? So for the first rectangle, notice each rectangle, right, is going to be the same. It's going to be two boxes, right? It's going to take two boxes because I need a value to the left, I need a value to the right. And we're going to take the value on the right. So we're going to take this value, and this value, and this value, and this value. So each one of these represents the value on the right-hand side of the rectangle. Notice the first value did not get used, right? Because it's on the left-hand side of the first rectangle. Right? So now we need to find our change in x, first of all. Right? So change in x. Notice that the x values are evenly spaced. So we don't have to figure out 10 rectangles. Right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rectangles. We do not need to figure out each one separately. We can find the change in x and find the sum of all the heights, and then just multiply the width times the height one time. Right? We don't have to do it because it's evenly spaced. Right? So we don't have to do each rectangle separately like an earlier video. So the change in x is just going to be 10 minus 0 divided by, we have 10 rectangles, right? You can see the 10 rectangles I drew in there, and you can see that we're using 10 values. So the change in x is 1, right? So no big deal, right? So the distance traveled, so we got a nice easy width there, is going to be 1 times, and now we're going to sum up. We're going to take the heights of the rectangles, right? And I should really put this is approximate, right? Because this is a Riemann sum is an approximation. Right, so that's going to be 1 times, because this is the change in x right here. And then this is all of the heights, right? This is the sum of all the heights. So 6 plus 10 plus 16 plus 14 plus 12 plus 18 plus 22 plus 12 plus 4 plus 2. Right? And that is 116. And we should put a unit on here. Now, what's the unit going to be? The velocity was in inches per second. The units here for distance is just inches. So that's how far the car traveled. It's about 116 inches. All right, so that's our right-hand Riemann sum. Let's do the same thing with a left-hand Riemann sum. All right? So same problem, same rectangles. We're just taking the left-hand value rather than the right-hand value. So now this time we're going to use, so we're using the left-hand side. So there's our first rectangle, second rectangle. You see them all drawn in. These will look a little nicer actually, these rectangles. Third, fourth, fifth, sixth, 7, 8, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Somewhere I must have not circled and not counted. All right, so the distance traveled by our little car here, it's exact same question, just different Riemann sum, is approximately, so let's get our change in x. Now, it's obviously going to be the exact same change in x, but I'll put it up here. All right, so the last x value is 10, the first x value is 0. We have 10 subintervals, so it is 1, right? That's our change in x. So 1 is our change in x. And then we're going to multiply that by, we're summing up all of those heights, right? So we have 0 plus 6 plus 10 plus 16 plus 14 plus 12 plus 18 plus 22. Oh, can I fit it in? I made this just a little further away, I think, this time. Plus 12 plus 4. There we go. And when we add those up, the distance traveled is going to be approximately 114. And of course, the same units, inches. If the velocity is in inches per second, the units for distance is going to be just inches. All right, there we go. There's the next one. Let's do one last one. Now, this one is a midpoint Riemann sum. I hadn't drawn in the rectangles yet because I need to draw these in just a little bit differently than the right-hand Riemann sum and the left-hand Riemann sum. So if we're doing a midpoint Riemann sum, I need to take the middle value. Now, I gave you a hint here. It's going to be 5 subintervals. But even if I didn't tell you how many subintervals, your bar has got to look like, your rectangle's got to look like this. Right? I need this one would be the left-hand one. This would be the right-hand value. And this will be the middle value. Right? So if you're doing a midpoint Riemann sum, you need to have 3 values. Right? Let's put that in there. Need 3 values in the rectangle for a table for a midpoint Riemann sum. If you don't have 3 values, who's in the middle? Right? So there's our first bar. There's our second bar. Whoops. Get carried away with drawing a bar here. Right? So the first rectangle has 0, 6, and 10 in it. The second rectangle, because they come together, right, has 10, 16, and 14 in it. There we go, 2. The third rectangle has 14, 12, and 18 in it. The fourth rectangle has 18, 22, and 12 in it. And the last rectangle has 12, 4, and 2 in it. Right? So now what if you messed up? You won't have a middle. If I accidentally kept drawing one of these rectangles too far, like let's say I put 0, 1, 2, and I didn't repeat the 2, right? I went over to 3, 4, and 5. Well, all of a sudden, I'm going to be realizing that I don't have the right number of rectangles. And it's not because you can't do a midpoint Riemann sum if you don't put the rectangles to go in the right values, right? So each bar shares the value, right? Right? So the first bar and the second bar share the 210. The second bar and the third bar share the 414. The third bar and the fourth bar share the 618. The fourth bar and the last bar share the 812. Okay? All right, so let's do our Riemann sum. Now let's do our change in x because it is not the same as the last one. So the change in x, right? So we have 10 minus 0, but we only have 5 subintervals, so this time it is a 2. Right? That makes sense. Right? So the distance traveled is going to be the 2, which is the change in x. And then we're going to sum up all of the y values, right? So I'm going to circle them. There's the middle, and there's the middle. So there's the first middle, second middle, third middle. That second bar is the worst looking rectangle I've ever seen. Fourth middle and fifth middle, right? So those are our 5 values. Right, so we have 6 plus 16 plus 12 plus 22 plus 4. Right, and so that would be the distance traveled. Actually, I'm just going to put equals till I get to the end here. Equals 2 times, right, and then that would be, that's the only one I didn't bother to write down, would be 6, 22, 34, 6 and 60, yes. All right, so the distance traveled is 120, and of course the units is inches. So there we go. All right, so Here's how you do Riemann sum with the table. I hope you like these examples, and thanks for watching, and bye for now.